Hi, welcome. My name is Dr. Phil Winder. I'm the CEO of Winder AI. If you haven't watched any of our videos before, Winder AI is an AI agency. We specialize in bespoke AI development and consulting. If you have any needs or desires at the moment for any of your AI projects and need some help, then please check us out. We'd love to speak to you more about it. Today's presentation is a recap of the State of OpenCon presentation that I gave approximately a month ago. Here, I was asked to talk in the open data track, so this talk is very much data focused, and we'll sort of dive into that in just a moment. I've got to take my time to do this because the original talk was only 15 minutes long. The slot was really short. But this time, I just want to take a little bit more time to go through the demo in more detail, talk about the code, slow down over some of the slides and things, and talk a bit more in depth about some of the thoughts and ideas I have. If you have any questions throughout this presentation, then please feel free to ping them across. If you're on YouTube or LinkedIn, you should be able to just use the comment section there, and I should be able to see them. Otherwise, you can email me at phil@winder.ai or just visit the Winder AI website to find our contact details. I think that's about it. So yeah, let's get going. Let me try and figure out this. Tell you what, let me get rid of that. Okay. Slides are go. So I've got two sections that I want to talk about today. This presentation is divided into two key sections. The first one, again, focusing on data, is the emerging idea of data sovereignty. Well, I say emerging because it's not a new thing. I think the idea of sovereignty, especially when it comes to data, is has been a well-discussed topic for a while, but I think it's just starting to become more and more important, both personally and commercially. And it affects different levels as well. You've got data sovereignty is a national concern. So sovereignty in a national guise might mean that you want to retain your country's data or use your country's data within the country's laws. There's also an idea of sort of personal sovereignty as well. I want to own my own data. Equally, for companies, the company has this perception or idea of sovereign data there. The company wants to own its own data and control how it is used. So depending on what context you're talking about, the needs for that are slightly different. And so I'm just going to go on a little bit of a ramble, kind of contrasting the ideas between sort of personal sovereignty and commercial sovereignty. But there is still kind of a desire and a need to build the case for data sovereignty, because the default standpoint for most businesses and most people is to just hand over your data. The cookie banners that pop up on every website, the vast majority of people still just click accept all because it's easier. And using a SaaS service or anything like that, we often do that because it's easier and kind of accept that we're handing over all of our data. But I think it is high time to kind of start making active decisions. And when it comes to commercial activity, you need to be very careful about the decisions that you make in this space. So yeah, this first section is all about that. The second section is a little bit more about this idea that I've been having, that large language models in general are amazing I/O interfaces. They're natural language, obviously, but I think we're just starting to scratch the surface of how they can be used. Obviously, people are focusing on applications, but I'd like to kind of talk about some of the ideas I've got about them being literally the interface for the business. And I've got a demo to show you there as well, which could be quite cool. And I'll go through some code and kind of talk about that a little bit as well. All right, so to begin with, the open data. So the Open UK are a non-profit based in the UK that promote open source ideas and benefits and the case for open source, basically. And we were in the Open Data Act track, and the we're lucky to live in the UK that has quite a formidable track record for open data. We have some great institutions like the Office for National Statistics and data.gov and various initiatives at a government level that help promote the use and acceptance of open data, especially when it comes to use within government. And to demonstrate that, I wanted to just go back to a previous presentation when I was doing a little bit of data science to ask the question whether there is a north-south divide still, because I live in the north up here near York, and the perception still is that there is a huge north-south divide, and that is expressed, or the perception at least, is that is expressed as a difference in income equality. So this was a bit of analysis that I did on some ONS data that that looked into the incomes in some very small geographical regions, and you can sort of browse to, if I get my face out of the way, you can browse to there we go, browse to this link and actually view it live, and you can zoom into some really quite small jurisdictions and regions, and this is the final plot where it subtracts the housing, the living costs basically away from income, and you can see that the red here, this is the areas where the income is still high compared to the living costs, and yeah, it's not as clear cut as north and south anymore. It's kind of like like an east and west versus the central kind of band of wealth in the UK. There's clear kind of adversity going on in Wales and sometimes on the East Coast here. And the whole point of this was to demonstrate that open data allows people to do analysis like this, and then you get more professional presentations of views of that data, like the Corruption Perceptions Index from Transparency International, which take public data, open data from around the world, and republish new metrics and new analysis based upon that data. And then that becomes open data, and it's this cycle of exposing more and more data to provide an explanation of what's going on in the world. And that's all fine, and that's all great, but everything can't be open. We can't have open data for everything, for obvious reasons. There's PII and privacy related reasons. There's security related reasons why you want to hold data. Commercially, there's a variety of threats why you want to keep your data private, and some of the most interesting ones are listed here. So we've got a variety of potential threats coming from cybersecurity concerns. For example, hackers and ransomware and viruses and things can contribute to a threat to your data. We've got industrial espionage on a scale that has never really been seen before around the world, and institutional and international law has an impact on that. Different countries have different legal definitions of what is okay and what is not okay, and that's now being played out on a global scale. Also, I've heard of a few companies that have had various significant impacts to their business based upon the loss of some very important data or ways of working that are proprietary and valuable. So yeah, kind of external and internal espionage is rife. Some more interesting ones are the government related surveillance that goes on, and this impacts it probably impacts you personally a little bit more than it does commercially. If you think of yourself as being part of a business, then you might agree or accept rather these practices happen, and you work within the laws of the country that you operate from, and therefore these are the laws, and so you have to accept it. But personally, you might have a slightly different opinion, And the rampant government surveillance that still happens even today is still it's an underreported topic. It kind of goes in and out of fashion in the media, in the mass media, but I wish it wouldn't, because it's happening all the time. And so I think this is a really interesting story, and we'll come back to the corporate data collection in just a moment. So in terms of the government surveillance that is still going on, here's a couple of notes for you to look up if it is of interest to you. I think probably the most interesting one there, if I was to point you to any of them, is this European Convention, the European Court of Human Rights ruling on the Convention of Human Rights with respect to the scanning that GCHQ does of all of the internet traffic, and there's quite a few sort of damning concerns in there. They were found, in violation of particularly like Article 8, the right to privacy. But in the end, it all falls under national security legislation. So it continues, but it's still a really fascinating read, because not often are the public allowed to view this information without a court's intervention. So irrespective of what you think, it's still a really interesting read. So yeah, check it out. And one of the main reasons why the UK is of such interest here is because of the transatlantic fiber optic cables that travel around the world. And I went down a little bit of a rabbit hole here, so I hope you find it interesting. But yeah, if you notice on this map, this is a map of most of the transatlantic fiber optic cables around the world, and you'll notice that between the United States and Europe and basically the rest of the world, vast majority of the fiber optic cables still come through the UK. There's only a couple that flow to Denmark, but yeah, the vast majority still go through the UK. And so I kind of got started asking questions about where do those cables actually land. And one of the most recent cables was installed on a random beach in Cornwall, and I kind of got in it. It's a Google sponsored data cable, which provides a huge amount of bandwidth, which is fantastic. But I kind of started asking the question, like, why this random beach in Cornwall? Like, why not Ireland, for example? It's geographically closer. Yeah, not sure it makes sense. So they chose this tiny beach in beautiful Cornwall, and I kind of started clicking through the links to find out where this place actually was. It turns out this Bude was, let me get rid of my face again, is it consists of one building, and then that's GCHQ Bude. That is a listening station for GCHQ where the cable lands. And I'm like, oh, okay, all right. So that's probably why they put it there, because all of the infrastructure is there. Yeah. And then I thought, well, let's just look up this site and actually find out a little bit more about GCHQ Bude. And it turns out that it was originally funded by the NSA. So the US's NSA funded for most of the infrastructure and the technology that exists at GCHQ Bude. So if you're a conspiracy theorist, then yeah, they're making it quite easy for you to read into this a lot. All right, going back to the commercial side of things, one of the funniest articles that I read recently was this one. So the idea here, the idea behind the case for data sovereignty is that as soon as you expose your data of any kind to a third party, then it is open to be able to be scraped, irrespective of the laws, because there's a variety of legal cases going on at the moment that are attempting to figure out where the line is when it comes to copyright infringement, and how models are memorizing the content and regurgitating the content, and whether it constitutes copyright violations or IP violations, trademark violations, things that already have a legal framework to work within. And those court cases are uncertain and ongoing. And in the large part, most people are just ignoring them for the time being. And so when OpenAI come out and start saying that they're angry that other companies are stealing the outputs of their models or using their models to train downstream models, it's a little bit ironic when they're going through the same process with original content providers as well. Yeah, so that was probably the best headline there from 404 Media, which I enjoyed. But it paints an important picture. It basically asks the question, like, what can we do about that? And if we do have sensitive proprietary information, then how can we prevent it from falling into the wrong hands? How can we ensure that it stays valuable to us in the long term? And I think probably one of the simplest ways of doing that is not using third-party systems, not passing data outside of your systems as much as you can help it. And this was originally the idea behind Helix, which is one of the. I'm a founder of Helix ML. I'm a co-founder. I've set it up with a few friends. It's a product that provides you with a Gen AI platform where we're specializing in use cases that require private or secure infrastructure to be able to leverage LLM and image generation like models on top of private infrastructure to try and attempt to avoid leaking sensitive information to third parties, but still gain all of the benefits of large language models and other Gen AI paradigms. So the overall case for data sovereignty within a commercial business is that your data is proprietary. It is a commercial advantage. You don't want to expose that data to anybody else because they will use it to retrain their models. They may use it directly. You have very little guarantees over whether it will or won't get used, and therefore the best way of achieving data sovereignty is to by maintaining the integrity of your systems, in the sense that you just don't pass the data outside of your systems, and something like Helix allows you to do that. So yeah, check it out if you're looking for a private Gen AI platform that adds this layer of security. Okay, so that's the first ramble. The second ramble is an emerging kind of idea that I have to use large language models as an interface for the business, but not just a human interface, also an API interface for the business as well. So yeah, let me take you across to my shared screen. 2 seconds. All right, let's bring my face back. There we go. And hopefully you can see this. So this is, let me get rid of all this. This is a quick repo that you can find on GitHub. Oh, have I got, let me just double check whether I've got the link later on actually. Otherwise, I will give you the link now. No, I don't. I'll pop it up at the end. Okay, so let's go back to that. Oops. So the idea here, or the idea behind this, is that I still believe that a large part of a business's value pertains to the data, the proprietary data that business contains. Obviously, that can be in many, many different forms. But one of the challenges that every business has is leveraging that data within the rest of the business, taking advantage of it. One of the key reasons for that is that data is highly siloed, and there's multiple layers of silos going on. There's like a strategic business level silo, in terms of different departments often don't have access to people in other departments. There's like a personal silo. Maybe some individuals have some very unique knowledge that isn't spread throughout the business, or maybe they have files on the desktop that are not exposed anywhere to the rest of the business. And so how do we kind of expose that data in a better way? Well, the traditional methodology is to attempt to do data engineering, move data about, centralize it, and expose it that way. But that still hasn't got rid of the problem of silos within data, because the silos still exist in real life. The departments still exist. It's like Conway's law. Everything always goes back to the structure of the business ultimately. So another way to think about it, well, let's accept that those silos exist, and then try and build in interfaces to those silos in a way that both humans and machines can use. And that's what led me to think, well, let's just use an LLM. So this is the beginnings of a very simple project where I'm trying to demonstrate using LLMs to communicate throughout the business across different silos. And I kind of decided to focus on sales in this example because it kind of applies to every business. And the idea here is that I'm starting to create individual personas with individual data sets for things that they specialize in. So the first agent I've got here is a lead agent. And this agent is responsible for capturing leads for prospects that are coming to the business for the first time. And if you imagine some form or process to capture that lead information, that then ends in this database here. We've got a simple DuckDB database with some dummy lead data inside. And there's a script here to generate some dummy data if you're interested. And then here's the code to actually create the agent. So a bit of background about this. I decided to use LangChain's LangGraph project to create some of these agents, but there's lots of other agent frameworks appearing. You likely might not even need an agent framework. It's quite easy to build agents in general just off the back of API calls. So yeah, consider whether you need one at all, especially for simple projects. Here I decided to play around with LangGraph, but small agents is a slightly lighter framework that has gained a lot of popularity recently. So that's probably what I'd be checking out next. Then we've got a couple of helper libraries here. We've got Typer and Rich to kind of provide some CLI goodness to everything. So won't go through that too much. Let me just show you what it looks like. So I'm already got the Python environment set up and stuff, and I've got this interactive mode. Actually, let me show you that. Typer is really nice because it comes with a load of freebies out the box. So the first one is like a nice help window, but we've also got completions and things, which is really great. Two ways of using these agents. One is like an interactive REPL, and the other one is just a single query and an exit. So we can use this tool as part of a script or as part of another pipeline, or we can use it interactively like I'm going to do here. So this is the lead agent, and we can basically ask it questions or do things in natural language, which in the backend, which I'll just show you in a moment, I'll show you the code actually. In the backend, it will create SQL queries to connect to this DuckDB database. The idea here is that both humans and machines can ask questions like this to provide it with information. Oh no. I think my colleague, Luke, has just upgraded production. So interesting thing to note was that I'm actually not using commercial Gen AI platform, I'm using Helix as the backend for all of the queries here, but I've literally just got a message on my watch saying, I'm just updating production. So yeah, thanks, Luke. Right, well, we'll try and run that again to see if it's finished. Oh no, it certainly won't work with that. Let me just try and run that again. And whilst that's doing that, I'm just going to show you the some of the code. Oh, there we go. So it's back up now. So this is the response that it's found. A simple list response. In the back end, if we were to look at some of the calls being made, it's basically just in a big list on the table, and it's converted my request from the last month to like a temporal query in DuckDB SQL. So let's have a quick look at the code to see what's going on there behind the hood. So we've got a class here that represents the agent itself. Various boring setup stuff. I think probably the most important thing in this whole process is the prompt, and this is where the prompt is encoded. We've got a big description of what the database looks like and the various parameters, the various fields that exist in that database. We've got the query from the user, and then we've got some clarifying instructions at the bottom. Lots of sanity checks at the bottom, because what you'll see is if I run that same query again, you probably keep doing that. Wish I had implemented history. Oh, did I manage to press it twice? I did. It's okay. We're not in a rush. All right, there we go. Right, so if I run that query again, or a couple of times, oh, look at that. We're getting completely different results now. And actually, it looks like it's not doing the filtering. Oh, and that time it did something again and got a different number of results. So this kind of highlights the randomness that's inherent with all LLM applications. Each time, I probably haven't quite set the temperature correctly, but each time we're getting a slightly different response, which is generating a slightly different SQL query, and in this case, it's generating slightly different data. On that note, actually, let me just have an aside. This is actually a very dangerous pattern to use. We don't want to allow the user to effectively create SQL queries, because in all likeliness that it's a security risk, in the sense that users I could ask a query, please let's try this live and see what happens. Stop pressing enter. Please delete all data. It would allow our users to exfiltrate information within our database that maybe we want to hide. Also allows people to potentially generate SQL injection techniques to delete data or mutate data when we might not want to. It looks like that it has correctly ignored what I'm asking it to do and is just returning a select statement. So there's a good level of protection there, but I'm absolutely not convinced that this is safe long term. The right way to do this would be to lock this type of query behind an API, behind a function call or an API. And you ask the model to generate the function call or the API call. And that way you can do proper sanitization of the input request and carefully curate the responses to make sure that they work much more stably and reliably. Okay, moving on. So yeah, that's the prompt. Prompt is very important. We've got we had a little bit of sanity checking here to remove any backticks if they come back, and then the response. So after the initial prompt has run, the tools call will then generate the SQL, run the SQL against the database, and then paste it back into another prompt. And then this is asking the LLM to interpret that data and format the data in a specific way. So you see that there's kind of a similar pattern each time, where it's like generating this sort of list of markdown like data, and that's just that prompt there. Yeah, and that's really about it. And then the only bit of sort of LangGraph that's going on here is the creation of the graph. And my brain kind of works in graphs, so I like this way of thinking. A graph is, as you know, it's a combination of nodes and edges, where nodes are, in this case, things like bits of work to be done. That the result of that gets fed to another node to do something else. And LangGraph basically exposes an API to be able to create a graph to process some very, complicated graph-like queries. For many agents, that's probably overly complicated, but I quite like it. And so that's the only bit of sort of LangGraph going on here, really. The rest of it is all wrangling, formatting, prompting, the usual. All right, so we've got lead agent. We can interact with it, which is great. But what about other agents? So I've also got two other agents here. I've got a sales agent and a sales engineer agent. If we just have a quick look at the sales engineer agent, the goal for the sales engineer agent is to build an agent, a graph that performs a requirements analysis and ultimately generates an estimate of the amount of work and the key phases required to deliver a project. So if you imagine you're a consultant, an AI consultant like me, and you want to help your clients, if you want to respond faster to your clients' requests for proposals, then you can create a simple agent like this to help you break down the actual requirements and come up with a bit of a plan, an implementation plan, start phasing and estimating how long each of those phases are going to take. So that's what the sales engineer agent does. Based upon the plan that they have created, then now comes the estimates of the number of engineers required and the time required, because ultimately we'll use that information as in a cost estimate. And then, again, lots of prompting here to do that. And there's the LangGraph again. Okay, so I'll maybe skip over that one, but you can use that in very much a similar way. It's got the same CLI interface. You can use it interactively or just query it. I think the really interesting part is the sales agent. So kind of a bad name, actually, but the sales agent is kind of a salesman persona. They want to speak to the person that creates the lead and to speak to the sales engineer to figure out what a project would look like, and then respond back to the customer with an actual proposal. So in the background, the sales agent is actually going to communicate with both the lead agent and the sales engineer agent. So let me just see if I can. There. So this is the actual code that is calling the lead. So let me go back. So we've got this prompt here, which requires information about the lead, the specifications that are coming from the sales engineer, and eventually a cost breakdown, which the sales agent is responsible for. Then they're going to use all of that information and generate a proposal. So in order to get the lead's detail, then we'll try and find that again. Where's the get lead details? Here we go. It's going to actually call the lead agent and run just a normal human-like query against the agent. Give me all the details of the lead ID. So let's go ahead and run this sales agent CLI. Oops. Nope. No, I need to export oops. There we go. Right. So we've got new CLI here, and we've got a couple of different commands, and I'm going to just list all the leads first. So this is going back to the lead engineer and saying, give me all the leads. And then the lead agent will return all that information, and you'll see it's very similar format to before. Now what we can do is we can start generating a proposal for a specific lead. So let's say 35. And now this is going through this big prompt here. It's pulling in all of the lead details. It's going out to the sales engineer agent. It's asking it for a technical specification and estimates of phases and how much effort it's going to be. And then it uses information I provided in another prompt for various prices for various different roles that could be contained within the project, and it'll use that information to generate a total cost for the project. So yeah, multiple calls going on here. So this takes a little bit of time because you've got to call the LLM each time. The graph is very similar, actually. I think in hindsight, we probably could have used specific steps in the graph. We could have created nodes that represent those various parts of the problem. But I found it kind of worked okay just by calling it with function calling. And here you go. This is the generated proposal, and the rich CLI project is used to generate a really nice markdown version of what was created here. You know, this was a heading 1, this is a heading 2. So it's Rich that's doing all the formatting here and making it look pretty. But you can see that we've got a pretty nice markdown proposal coming out here. We've got an example of a timeline. We've got implementation ideas. We've got specific technical recommendations. We've got an estimate of what the team might look like, and we've even got some costs as well. It's come out with a huge number though. So we would need to actually generate the calculations that are being done here, because I don't think that, well, if all senior engineers received 1.2 million, I think they would be very happy, but it would mean that nobody could afford them. So this highlights another problem that we often have with LLMs is hallucinations. And basically, it's not a great word. I don't love it, but it's basically the idea of it's just predicting what should come next. It's not actually doing a calculation. It's not using the numbers here. Again, if we wanted to do this properly, then we would probably build an API to ensure that the calculations are correct, rather than allowing the LLM to do the math. Oh, another important thing to point out here is that here's the example sort of settings that you need to set in order to pass in some credentials to query Helix in this case, or OpenAI, or whatever. I'm using a very, very small model. I'm using Llama 3.1 8 billion, which is quantized to 8 bits. So this is a really small sort of 8-9 gigabytes of RAM model in order to generate this. And so obviously it's not the best at doing maths and things. If you were to use OpenAI or whatever, it would probably do a better job. But this is all being done with a very small model, which I think is quite a feat in itself. So yeah, quite pleased about that. Yeah, so this isn't meant to be a finished thing. This is just a very quick example I hacked together to kind of demonstrate the beginnings of a pattern that you could use yourself here. Again, just to recap, the idea is to encapsulate different parts of the business, and how you do that could be quite interesting. You could just do it on like a departmental basis, where you attach all of HR's data to one single HR agent. Or you might try and split up the problem a little bit more and have sub-agents that are specialized in particular topics. Like there might be a HR agent that specializes in policy, or a HR agent that specializes in granting holiday leave, things like that. And you might end up with a situation like this where it's all from a very similar domain. We've got a sort of a lead agent, a sales engineer agent, but they all work together to achieve tasks. And I think really the intelligence begins to emerge when you start connecting these things together. You allow the sales engineer, the sales agent to communicate with the lead agent, or the HR bot to communicate with both the policy HR bot and the leave granting request bot. So yeah, let me know what you think about that. I'd be interested to find out if anyone else is sort of thinking about these things and how they're approaching it. I guess it's a very agent-heavy conversation. I think the novelty here is trying to change the way that people think about how to use agents. At the moment, it's very sort of use case focused and capability focused. I want to sort of shift the conversation to trying to map the agents back to the business domain a little bit better, because I think ultimately they will provide a more generic and more powerful architecture that will work with multiple different use cases. Yeah, okay. So hopefully you're still with me. I'm just going to have a quick look at the questions, see if there are any. Oh, thank you. Yeah, there are a couple of questions. So let me go back here. I'm just going to bring up. Let me just leave that up for a second. So do you, thank you, Tiago. Do you leave it to the model to find the synonyms between the user query and the DDL of the SQL database? Did you work with it? Yeah, okay. So the question is basically how are you using the LLM to generate the query for the database here? In this code, I effectively allowed the LLM to generate the SQL query for me in its entirety. So we are relying on the LLM to convert the user query into an intent that is actually addressable in the database. It can do that because it knows about the database, so it can kind of infer about the types of things that it can do. But in my experience, there's a couple of problems with that. Well, firstly, it's unsafe. Secondly, it goes wrong very often, as you saw in the demo. It changed its mind each time. So what I would recommend is thinking more in an API-driven way. So the database is just one type of live information source. Think of it as just another API. And typically you think about the interface, the design of that API to access that data to represent the domain. And so that's really what is needed here. You need a wrapper over the top of the database to better represent the domain. And then in Helix, for example, we use Swagger specs, open API specifications to describe APIs. And within that, you have fields like descriptions inside the specification itself. And you can use the description to help the LLM decide when to use that API. So if you've got like a users/search API, the description would be, use this API to search for users. You can use a filter like this, like that, like this. And you're literally telling the LLM how to use the API. And that works really well and really reliably. Yeah, and that's what we use in Helix. Here, if you're actually allowing the LLM to generate the SQL to directly query the database, then you would need to invest a lot of time in prompting to try and constrain that behavior. Yeah, hopefully that makes sense. But fundamentally, it's the power of the LLM. It's the inference from the LLM that converts the intent from the user to a domain-specific API or SQL query. Okay, and then we've got another question, another recommendation for new content. Thank you, Ankur, is asking how to improve the retrieval mechanism in RAG using reinforcement learning. Okay, well that's great idea for a future topic. I'll note that down, but I'll just try and concentrate on this topic for the time being, if that's okay. So yeah, this is just a quick sort of overview of the whole architecture that I've taken you through there. I think we've done that to death, though. So the only final thing that I promised you was a link to the repos. You can take a look at this yourself. So let me just find that. It's there. And let me pop it on a banner at the bottom. There we go. And if you'd like to take a look at the code, that's where it lives. It's github.com/WinderAI/data agents. So I'll just leave that up for a couple of minutes. And yeah, oh, you can ignore the workshop. That was something we did live. But yeah, here's my contact information. If you'd like to follow me on LinkedIn, that QR code will take you to my LinkedIn page. Otherwise, yeah, you can reach me at Winder AI or Phil at Winder AI. And yeah, hope you enjoyed that. If you got any more questions, then just reach out to me. Otherwise, I'll leave it there. Okay, no more questions. Thank you, Tiago, again. Appreciate it. If you need anything else, then feel free to reach out, Phil at Winder AI. I'll see you next time. Thanks a lot. Bye-bye.